Good day and welcome to the Math Salon. I'm Dr. Anumendem. Today we're going to look at 4 complex number short questions expressing complex number from the form a plus ib to r into cos theta plus I sin theta. So the polar or trigonometric form. So express the following complex numbers in the form r cos theta plus I sin theta. When we are given a complex number to express, let's say if we have a complex number z which is equal to a plus ib, we know that r is called the modulus, and that is actually the length of that complex number, and that is given by that. We know theta is the argument of z and is given as a tangent, the tan inverse of the complex divided by, the imaginary divided by the real, b on a. Just keep that in mind and we are going to apply it soon. If that is the case, you also have to remember complex numbers can actually be plotted on a Cartesian coordinate where the real axis is the real z and the vertical axis or the y-axis is the imaginary, which means we have something like this. So this is the real part of that and this is the imaginary part of z. So I can actually have a complex number here z, which is a plus ib. That means it has a length here a and this b. So we can do that. If we can do that, because we also have ideas of angles, trigonometry coming in, then we can also recognize our quadrants. This is the first quadrant, second quadrant, third quadrant, and fourth quadrant. And this will help us to determine the argument of the angle given a particular complex number, as we will see shortly. So let's say we have this complex number, then we know that the modulus r is simply the square root of the real part squared, 1 squared, plus the imaginary part squared, root 3 squared. If you do that, 1 squared is 1, root 3 squared is 3, 3 plus 1 is 4, so this is the square root of 4, and that is 2. For the argument, well, let's just say theta. So our theta should be equal to the tan inverse of the imaginary part divided by the real part. So that's root 3 divided by 1. But before you write that answer, you have to ask yourself, in which quadrant is this? I'll just try to indicate here. So this is the real z. This is the imaginary z. This is positive, so we are in this part. So 1 is positive, so we are in the positive axis of the real z. The imaginary one is also positive, is root 3, so we are also there. So we are in the first quadrant. So the angle we are looking for is theta, and that's an acute angle. So looking at this, we've already seen in one of the videos that this is just 60 degrees. So this angle is 60 degrees. In that case, we can now express it as 2 cos 60 degrees plus I sine 60 degrees. So this is this complex number in that form. So let's look at this one. We look for the modulus. R is equal to the square root of the real part squared, 1 squared, the imaginary part, that is minus root 3. So I'll put the minus root 3 in brackets. Squared, square root. If you do that, you see this is the minus squared is squared. So this is simply 1 plus 3. And that's simply root of 4. And the answer is 2 again, like before. So now we are left to look for theta. Theta is the tan inverse of the imaginary part, that's minus root 3, divided by the real part, that is 1. But in order to be able to get this angle, we have to also think, in which quadrant is this one lying? So we look again. This is the real z, imaginary z. The real part is positive, is 1, so it's to be in this direction, either one of these. But the imaginary part is negative, so it should be under, so which means my complex number is somewhere here. So this means this is in the fourth quadrant. Fourth quadrant angle can be measured in the opposite sense Or you can, of course, measure the whole thing up to this one. It's okay. So in this case, this is just minus 60 degrees. So this minus 60 degrees here. And then my complex number can then be written in the form 2, the bracket cos minus 60 degrees plus I sine minus 60 degrees. Let's go to this one. Once again, R is equal to the square root of minus 1 squared plus minus root 3 squared. And again, it's the same. It's just root 4. And that is 2. Our theta this time is the tan inverse of minus root 3 all over minus 1. Theta is then the tan inverse of root 3. But remember, we said you cannot determine this angle without knowing where it is. So let's look for the quadrant where that is. Real Z, imaginary Z. So our real part is negative, so it should be somewhere here. The imaginary part is negative, so we are under here. There are two ways you can measure. You can also measure this like this. Or you can go all the way around to that point. So if you want to do that, okay, then it means you say this angle here is going to be 180 minus the one you have, because actually what you would have calculated is this angle. The theta would have calculated is this small one, but we need this one. So in order to get this one, we take 180 minus that. So this will be 180 minus 60 degrees, and that is 120 degrees. So our complex number then will be 2 into cos of 120 degrees minus, 120 degrees plus I sine minus 120 degrees. So you are in the opposite direction, so you should get minus there. Then we come to this one. So R once again is the same. That's the square root of minus 1 squared plus root 3 squared. That's equal to the square root of 4, and that is 2. Our theta is a tan inverse of root 3 divided by minus 1. And that's tan inverse of minus root 3. We know again it has something to do with 60, but we have to check. In which quadrant is this? So here, my real is negative, so it's somewhere here, minus 1. The imaginary is positive, so it's somewhere up. So this is in the second quadrant. If that is the case, then it means this is the angle we are looking for. But what we would have calculated there, that is in this form. So my theta would be 180 minus 60 degrees. And that's 180, sorry, that's just 120. So it means my complex number can then be written in form 2 cosine of 120 degrees plus I sine 120 degrees. Hope that was okay and that you understood, you could follow. If not, yeah, leave us a comment and we will try to improve. Thumbs up, subscribe, share with your friend, especially those that don't have phones or computers at home or that don't have internet. Please share with them. Thank you.